This differential equation is a little more interesting. So here we have y prime plus 1 over x times y equals 0. So our p of x is equal to 1 over x, and our g of x is equal to 0. So in here, we definitely have a discontinuity in p of x, x equals 0. X equals 0 discontinuity. And so the solutions are going to be divided, everything from negative infinity to up to 0, and then everything from 0 up to infinity. And there will be a removable discontinuity. So in this one, let's take a look. So we can solve this. It's a separable equation, and we've solved this a few times before. So its solution is just y of x is equal to c over x. And so yeah, there's going to be some problems in that if we try to have x pass through 0. So x, y. All the solutions look something like this, and this is 1. So it goes down, and then it jumps. It has a jump discontinuity, and it goes up, and like that. So that's going to be when c is positive. If c is negative, then we have pretty much the opposite. There we go. I drew that pretty well. And then the curves can get tighter and tighter. So kind of an exaggeration. It can hug for a really long time, get really close, and then go away. And it can do that for all of these. So you can get really, really close to the origin, but you can't really touch it unless c is 0. We'll do that in a sec, but let's see. Those aren't going to be terribly accurate, but something like that. So definitely most of the solutions can't touch most of the y-axis when x equals 0. There is one though. If c equals 0, there is a solution. I'm going to draw that on a separate graph. So let's see if I can draw a little thinner line here. All right. If c equals 0, we end up with a discontinuity there that can be removed, and then a line. And so, right, when you plug in y equals 0 to this differential equation, it does work out. And even though you have 0 over x and x turns into 0, it's okay. You can kind of remove that. So you have to be a little careful. Technically, the solution only exists on the left half or the right half, even when c equals 0. But you can remove that discontinuity. But that's the idea. So we were able to, since it's a linear equation, we were able to just look at the discontinuities of p of x and g of x. P of x had one discontinuity when x equals 0. G of x was fine. It didn't have any discontinuities. From there, that x equals 0 split the negative infinity to infinity for x into negative infinity to 0, and then separately 0 to infinity for the solutions to this differential equation.